How are you guys doing today? I feel like I'm seeing after a long. So we did see Wednesday, Thursday, Friday, Saturday, Sunday, 5 days. That feels like a year. Okay, so today we're supposed to have 10.2 homework 2. I'm going to change that to next week. So 10.2 will not be due tonight. It will be next week. Also, one more announcement. Initially, I was thinking of holding an online class tomorrow, but I decided to cancel it. So there will be no class tomorrow. Whatever materials we're going to cover today, your exam will be up to that material. And I'm going to tell you what to expect in the exam today. Okay? Any question, comments, concern, complaint? So tonight your homework is 4.5, 5.1, 2, 3, and we are going to finish 4.4, 5.4, so 5.4. 5 sections. 5.1 to 5.4 and 4.5. Okay. 5.4 is a small section. So I think you'll be able to finish the homework tonight. And tomorrow there is no class. Yay. And tomorrow it will feels like 104 degrees. So if possible, try not to go out. It will be hard to stay outside tomorrow. Not only tomorrow, also Wednesday. But at least Wednesday it will rain in the evening. But tomorrow will be really bad day. So stay careful. Any question before I start? No. So in our last class, the last thing we did was multiplying polynomial. And if you remember, I showed you both ways. Either you can distribute or you can use a table to distribute and then combine like terms. Whatever is easier for you, you do that. For my case, I'll just use normal distribution. So I'll take one of these and point. Wrong. Okay, so for distribution, I'm going to take one of these and multiply all three. This is 2x cubed multiplying 8x squared minus 7x plus 3. Then I'm going to take the next term and multiply all of this. So plus 5x multiply 8x squared minus 7x plus 3. And then it's just distribution, single distribution monomial. One monomial and one trinomial. So what do you get from the first term? 16x to the 5th power, perfect. The next one, this with that. Go ahead, no problem. Negative 14x to the 4th, perfect. The last one, oh, I went too far. plus or minus plus 6x to the third. So in multiplication, we multiply the numbers, and for variable, we add their powers. Now comes the next one. Who would like to try the next one? Go ahead. 40x to the third. Next.
Would it be 35x, negative 35x to the second? Or just
Seconds. Because you see two of them. Negative 35x to the second. And lastly, the last one. Plus 15x. And then you combine like terms. So if it's easier for you to write one after another, write that way. Or if you can combine all of them horizontally, you can combine them. For my case, I will just combine them as they are. I will write them below one another. So this is x cubed. We have 40x cubed. This is x squared, so don't to be confusing. Let me rewrite everything. So 16x to the 5, there is no more. We have 14x to the 4, and we have no more. Then we have two of them here, x cubed. So what do you have? Plus 46x cubed. Oh, and then we have x squared and x. So 35x squared plus 15x. So basically we had only one like term. Two like terms, that's it. Now we cannot combine them anymore because all the powers are different. In order to add and subtract, our condition is you have just same variable and same power. Question? No question? So definitely you'll have one of these in the final exam and also in class exam. Now section 5.4. 5.4 is same thing, but they're saying, well, you don't have to use FOIL. You can simply use a formula to distribute. So either you memorize the formula, make your life easier, or if you hate the formulas, then ignore, just use distribution. It's up to you. But personally, I'll suggest you memorize the formula. So there are three formulas we are going to memorize. The first formula is if you have plus or minus in the base and then the power. For example, a plus b with the power 2 or a minus b with the power 2. And this formula works only for power 2. For 3 power, you cannot use that. For 4 power, you cannot use that. Only for power 2, you're allowed to use that formula. The formula says all you have to do is instead of multiplying it twice, a plus b and a plus b, you can simply put a square plus b square and then add twice their product. So a square plus b square, both of them are from the base, and then you just combine them by multiplication and put twice amount. So plus twice their product. For minus, same thing. A square plus b square is always plus, okay? A square plus b square. And for minus, you subtract twice their product. For addition, you add twice their product. For subtraction, you subtract twice their product. That's it. Now, the last formula says, well, what if you have a square minus b square? It's not a minus b square. It's a square minus b square. So you have two perfect squares and a minus between them. I'm talking about this formula. If you have two perfect square minus between them and you want to find what they give you, we call them difference of perfect squares. So they give us the addition and subtraction of their bases. So our base is A here and base is B here. So we call them actually factoring. When you factor A square minus B square, you get the sum of their bases times their minus of the bases. So A plus B times A minus B. In other words, if you see A plus B times A minus B means the two terms you see the exact same term, just their signs are different in the middle. You don't have to use FOIL to multiply them. All you have to do is take the first term A, square that, minus, take the second term, square that. And you need to use that a lot in this class. So you must memorize this formula. Even if you don't memorize the binomial scoring, it's fine, but you have to memorize the difference of partial squares. Okay? There is no other way for difference of partial squares, especially if they ask you to factor. For factoring, you have to memorize this formula. Now let's do some example. Let's say we have 6x plus 2 squared. Two choices. Either use this formula or you can multiply twice. Let me use the formula. The formula says take both of them, square them, and then add twice their product. So first thing square plus second term square, and now we're going to add twice their product. So first one is 6x, second one is 3. That's it. This is the formula. And now all you have to do is simplify. Not simplify, rewrite it. So 6x whole thing square. What do you get from there? Go ahead, Angel. Sorry, not Angel, Martin. Perfect. 36x squared. We are using power rule. Anything we have more than one term, more than one element on your base, you have to distribute the power. It was like the rule. A, B to the power n means A to the n, B to the n. So it becomes 36x squared, not 6x squared. Now the next one. We have three numbers, one variable. So what do you get when you multiply the three numbers? How much you get? How much? 36x. What? How I get 6x? 36x plus 9. If you want, you don't have to do the middle line. If you can do it mentally. For example, we know first one square is 36 squared. 3 square is 9, and then their product is 6 times 3 is 18. Double of 18 is 36. So if you can do it mentally, you don't even have to write the second line. You can do everything mentally. That's why this is a cool method, because for distribution, you have to use FOIL, combine like terms, rewrite, 3 steps. But here you can solve it only one step. Not solve, you can rewrite in one step.
So if we use the other method,
No, same thing. You get the same result. Okay, try the next one by yourself. Try using this method. If you get stuck, then use FOILing method. So the same formula, the only difference is you're minusing and subtracting twice their product.
Why wouldn't it be 30x? I mean 36x to the third? Because they're not a one.
Because there's only one x and you're squaring it.
But isn't there like an imaginary one like on top of there here?
Okay, so if we have xy to the power n, what's the formula? If you have xy to the power n, what do you do with this power? What's the power rule says?
You're on and x. Yeah,
So what do you get? Tell me what do you write? X to the what?
X to the
No, this is n.
Oh,
This is n. It's not a number. It's n. Any number. N. Good. Now you have 6x with the 2 power. So what do you supposed to have? 6 square and square. See? You will get 3 if you had x square and then you're multiplying by x. So when you're the same base you're multiplying, you add the powers. But here you only one base, so you're distributing the power. Are you guys ready for the second one? Who would like to tell me the answer? Any volunteer? Martin. As for y square. And he is perfect. So you can write it in one line. Angel. So I have negative 20xy. So we have 5x squared minus 2 times 5x to y plus 2y to the second power. If you put negative 2y, then you cannot put negative in the front. Negative works only once, not twice. So if you look at the formula, see, 2a positive b is written here, not negative b, even though we have a negative b here. So what happened to the negative sign? It came down here. So you have two choices. Keep plus here and then 2 times a times negative b. So you have negative and positive times negative. Or simply turn this into negative and everything becomes positive. Okay. Because you're using the negative to subtract. That's all you have to do. And then one more. Oh, and then so these are the first two binomial squaring. And now you're going to do an example on difference of perfect squares, which is very important. So x plus 1 times x minus 1. Observe, we have same thing on both factors. X here, x here. 1 here, 1 here. Okay, same 1, same x. So the rule says, if you have the same two terms, adding and subtracting, all you have to do is square them and subtract them. So take the first one, x, square that, and always subtract the second one and square that. In other words, it becomes x minus 1. Sorry, x squared minus 1. Yes, you can use FOIL, but you have to memorize the formula anyway. So that's all you have to do. You can write this product in one line. You don't have to write the second line, you can simply write the third line. Any question? Who would like to try the next one? 4x plus 3, 4x minus 3. Mariam. Wonderful. 16x squared minus 9. See, in one line. You may wonder how? Well, the same rule. You have 4x and 4x, the exact same thing. And you have 3 and 3, exact same thing. The only difference they have is one of them is plus, one of them is minus. So as long as you have two different signs, but the same thing, it's the first term square minus the second term square. So you take 4x square that quantity minus take 3 square that quantity. So 4 square x squared becomes 16x squared and 3 square gives us 9. Question? Okay, I have no more really. Let's try one more. Let's say we have other way around.
Well, method, do we get the same answer?
Same answer.
Okay.
Let's go other way around. Okay, let's see how x squared minus y squared. Which two factors gives us x squared minus y squared? Do you want to say it again? Perfect. You observe the base. There are two bases we have. So all you need to do is add the bases, subtract the bases. So we have x plus y, x minus y. One more. We're going to do more in chapter 6. EF. Let's say we have x squared minus 4. 4 doesn't have any base. Sorry, 4 doesn't have any power. So what do you do this time? Rewrite 4 as 2 squared. So we have x squared minus 2 squared. Now we have a power and minus between them. So what are the two factors we have? X plus 2, x minus 2. The order doesn't matter, you multiply. Okay, so if you go this way, it's called factoring. If you go that way, it's called multiplying. But they work vice versa, either way. And with this, you're done with 5.4. 5.4 has another formula for cubic, but for exam, we don't have to worry about the cubic formula. For homework, just follow the instruction, and then you'll be fine. And if you need help, we'll go over that next week, next Monday. Okay, now starts 10.2. We have 1 hour. So we are going to finish 10.2 in 1 hour, and your exam will be based on only chapter 5 and 10.2. Okay?
Well, it's just only about chapters 5 and 10.2.
So there will be no 6 at all.
I'm sorry, just on the last one you did, like, in one instance, like, so you get x squared minus what, like, what? Why
Our
would you
goal
have
is to have 2 perfect squares.
two? So that's how you want to solve the question.
So 4 is 2 squared. So we want to see the squares. In 4, we don't see the square. So rewrite so that you can see the square. Why don't you see the square?
Oh,
Because
so-
we can only use their bases.
Okay, so only if you have like a square, if you have anything squared.
Okay, so 10.2 connects with 5.1 exponent rules. So before we learn many exponent rules, for example, let me refresh your memory. If you have a, b with the power n, we say it's a to the n, b to the n. Do you remember? And then if you have division to the power n, it's same thing, right? A to the n divided by b to the n. What else we learned? We learned if you have same base, but you're multiplying two different powers, you add the powers. For division, you subtract the powers. Do you remember all these rules? Okay. Now we are going to learn one more rule. It's radical. If you have anything with the whole number, with the fraction power. So if it's a whole number power, we don't care, whole number power stays same. But if it's a fraction power, it means you actually have some type of radical, nth radical of a. So if you have a to the 1/2 power, whatever we have on the denominator, that always goes inside your radical. Not the radical, but inside the radical symbol. So this becomes square root of a. So we have the invisible 2 here, but we don't use the 2. We simply write square root of a. We already assume it's square. Okay, so this 2 is always invisible inside the square root, but we do have a 2 there. If you have a to the 1/3, which type of radical is this? 3 roots. It's the cube root of a. So besides 2, every other number becomes visible. And you can go other way around. If you have a radical, you can rewrite using fraction power. So they go both ways, like this one. Either you multiply, get perfect squares, or if you have a perfect squares, you get two products, product of two conjugate.
What was a to the 4/3 power? Would that be the same? Like,
so this will work as let me refresh your memory with a to the n and m. What's the rule for this? A to the n. If you have two powers together, what do? Multiply, say to the mn. Now, instead of, if we have 4/5, this is same thing. It's a to the 4 and then multiplying by 1/5 power. So you're multiplying 4 times 1/5, it turns into 4/5. But what is 1/5 power? What does that mean? It's the 5th root of whatever you have in your base. In our base, we have 4. So if you have a number on the numerator and a number on the denominator is the radical and numerator is the whole number power. So always denominator goes inside the radical symbol, and whatever you have on the numerator, it's the whole number power goes inside the radical. I'm supposed to have one more page here, but for some reason I don't. So we have nth a here. Whatever we have here, we call them root or index. And whatever we have inside the radical, they have a special name. We call them radicand. So we call them radicand if they're inside the radical, but we call them base if they are in fraction format. So here our a is called base, but the same a, if it goes inside the radical, we call them radicand. Okay, so they are radicand or base. Base if you have the fraction power, radicand if it's inside the radical. Same thing, this thing, the power, if it's in the fraction form, we call them power or exponent. But if it's in this format, we call them index or root, and root of a. Okay, so now let's do some example. 4 to the 1/2 power. What does that mean?
2 right?
2 the square root of 4. We have a 2 there, but this 2 is invisible because we never write them. So it's simply square root of 4. And what is square root of 4? 2. So 2 to the 1/2, it may look unknown to you, but if you rewrite it as square root of 4, now you know the answer. So whatever is easier for you to visualize, you can use that formula. You can give me 2 from the first line, but you can rewrite as square root of 4 and then write the 2. How about 64 to the 1/2 power? Square root of 64, and it becomes 8. So for square root, from my opinion, it's always better to rewrite in this way so you can see what's the answer. Besides square root or 1/2 power, for every other number, the easier method is rewrite the base instead of rewriting your exponent as a radical. What does that mean? Look at the next one. We have 64 to the 1/3 power. Now 1/3, before we go to the 1/3, let me ask you, how do you know square root of 4 is true? How do you know that? You need to multiply 2 twice, you get 4. And y square root of 64 is 8. Because you're multiplying 8 times 8, that's 64. So do you observe whatever radical we have or whatever denominator we have, your goal is to find one number that you multiply the denominator many times and it becomes that. So square root of 4 is 2, because if you multiply 2 twice, it becomes 4. Square root of 64 is 8, because you're multiplying 8 twice, it becomes 64. Now, 64 to the 1/3 is cube root of 64. It means you are going to find same number. How many times you have to multiply to get the 64? 3 times. Good. So can you think of a number, if you multiply that 3 times, it will turn into 64? 4. So instead of writing cube root of 64, you can actually rewrite the 64 itself as 4 to the 3 power. Why we did that? Because what happens when you have 2 powers together? You multiply them, right? But when you multiply a number and a fraction, what happens to the number and the fraction? They cancel one another out. You have 3 as a whole number and 1/3 as a fraction. 1/3 of the 3, they cancel out. So what's the answer? 4. So cube root of 64 is 4. So you can do this in 2 ways. Rewrite as cube root of 64, or rewrite 64 itself is a 4 cube and then cancel the denominator. Whatever remains, that's your answer. Okay? Is there anybody who is confused? Nobody? Well, let's try the next one. Do you remember having a negative and not having a negative? That makes a difference, right? So -9 to the 1/2. What is our base here? -9 or only 9? What's the difference between this and this? Are the same? You have a parenthesis, everything inside is your base. If you don't have a parenthesis, it means it's a multiplication. So it's negative times, and for 1/2 power, it's better to rewrite as square root. So we get -9 times, this times looks weird, let me just write this. -9 times square root of 9. So negative square root of 9. So what's the answer? We still have to bring our negative down because the multiplication, and 3. What would be the answer for this one? -9, everything into the parentheses to the 1/2 power.
Other.
So if you rewrite this, you have to rewrite as square root of -9. +3. What is 3 times 3? But what do you have inside the radical? Okay, so can it be +3? You may think it's -3, right? What is -3 times -3? +9. But what do you have? -9. So is it possible to get an answer here as a real number? So it's not real. It does exist in the imaginary world, but in real world, it doesn't exist. 3i. The answer is actually 3i, which you're going to learn in chapter 10. But for now, it's not real. It does exist, but it's not real. It's imaginary. If you know your I, use I. If you don't know I yet, you can write not real or doesn't exist. So see, having a parentheses and not having a parentheses makes a huge difference. If you don't have a parentheses, it's a real number, -3. If you do have a parentheses, it's not real anymore. It's an imaginary number, 3i. The answer is actually 3i. If you know the imaginary number. If you don't know the imaginary number, ignore. Okay, the next one. What is our base? -81 or only 81? Only 81. So we have to rewrite only the 81. If you multiply 3 4 times, 3 times 3 times 3 times 3, it will turn into 81. So what happens to the power 4 and fraction 4? They cancel one another out. So we have negative from multiplication and 3 from the base. This one, we just ignore. Questions so far? Okay. Now, the thing I discussed before, what if you have two powers? One is in the numerator, one is in the denominator. What happens? It means you have to work with both. So if you have a to the m over n, you can rewrite a to the m power and then radical n. So denominator always is radical and numerator is always the exponent, the power. And this thing will be equals nth root of a to the power m if both m and n are positive. Okay, if both of them are positive, then how you write them, it doesn't matter. You can put the power inside the radical, or you can write the radical inside the power. They are interchangeable as long as both of the numbers are positive. If it's a negative, sorry, my bad. If the base is positive, not the power. If a is positive, as long as your base is positive, you can change your fraction with the whole number. It doesn't matter. You may wonder, well, what's wrong with negative base? For negative base, it's not true. Okay, I'm going to show you why it's not true when you learn about imaginary number. For real number, it doesn't matter. For imaginary number, it's not true. So if your base is positive. And also the same scenario. Having a parenthesis or not having a parenthesis makes a huge difference. If you have a parenthesis inside, sorry, if you have a negative inside the parenthesis, but all of your denominators are even numbers, then it doesn't exist. Why not? For example, this one. We have -4 square root of x. So square root as our radical. And you already seen There is no number if you multiply twice, you get negative answer. That's why this doesn't exist for now in real world, but later it will become I. It's 2I. Same thing, the 16. We have our base 16 and our radical is 4th. So 4th root of 16. There is no number if you multiply 4 times and it will turn into a negative. It's not possible. If you multiply 4 positive, it will be positive. If you multiply 4 negative, it will turn into positive. So there is no way you multiply the same sign 4 times and turn into negative. That's why 4th root of negative 16 doesn't exist. It's not I, it's just something different than I. So you have to be very careful. In your base, if you have a parenthesis or if you don't have a parenthesis. If you don't have a parenthesis, it's a multiplication. If you do have a parenthesis, then you cannot have an even root. The first one is square root, second one is 4th root. You cannot have them. Okay, clear? So this is the thing you have to memorize or remember. But guess what? Odd numbers, they're so generous. They don't care about positive base or negative base. As long as the power is odd or the radical is odd, they always give you something positive, something real back. Okay? So odd number doesn't have any problem. The problem with the even numbers. So odd number 64 to the 2/3 power. Let's keep our 2/3 because this is exponent. And rewrite the 64. How would you like to rewrite 64? A number to the what power? 2 power or 3 power? Which one? Who can guess? Martin. 3. Why 3? Great. Our goal, see, we hate 3. Why? Because it's on the denominator. We hate denominators. So you have to cancel the 3 from the denominator. We want to rewrite the 64, some number with the 3 power. So what number to the 3 power is 64? 4. So we rewrite this as 4 cubed. And now we are happy because 3 and 3, they just simplify with one another and they would die. There is no more denominator. So what is left then? 4 from the bottom and 2 from the power. So what do you get? 4 square means 16. So see, they gave us something so hard looking thing, but it came down to the simple number 16. Any questions so far? No question? Okay, the next one. What is our base? Negative 64 or only 64? Only 64 because you don't have any parentheses. So this negative is a multiplication. So we are going to rewrite only 64. And how are you going to rewrite something square or something cube? Power cube, because our goal is to cancel this denominator. We hate the denominator. So again, 64 is what number cube? 4 cube. So the cube and the 3, they cancel. Now what do we have? Negative from the outside, 4 from the base, and 2 from the power. So what's the answer? Negative 16 or positive 16? Which one? how is this negative connected? As a base or as a multiplication? Multiplication. So answer has to be negative 16. As long as you don't have a parenthesis, it's a multiplication. Parenthesis means base, like the next one. We have a parenthesis around the negative, so our base is negative 64. So we are looking for some number 3 times. Which number 3 times is going to give you negative 64? Which number 3 times is going to give you positive 64? 4. So which number going to give you, if you multiply 3 times, negative 64? Negative 4. Remember, add number, for add power, if you multiply negative add many times, it becomes negative. So negative 4 times negative 4 times negative 4 is negative 64. We cancel the 3 with the 3. Now what is left on the denominator, on the base? What is left on the base? Negative 4. And what is left in the power? Square. So what's the answer this time? Positive 16. See, the second one and the third one, they look all the same, but definitely they are not same. One of them give us negative results, the other one give us positive results, same as the first one. So this is the hardest thing, the most hardest thing. Remembering about the negative rules. And that is the worst thing in exponents.
So why this is the end?
Because you can find one number multiplying 3 times, the same number multiplying 3 times turn into negative. But if you cannot multiply the same number at even time, and they become negative. The main thing is, can you find a number if you multiply add many times, denominator many times, and it becomes the base? For example, if the answer was negative 64 to the 1/2. So your denominator is 2. So what is your goal to find? Same number multiplying how many times? Twice. So can you find a number multiply the same number twice and turns it to negative 64? No, because if you multiply positive 8 twice, it's positive 64. If you multiply negative 8 twice, it's positive 64. So what happened to the negative 64 our base? We can't find any number. So in this case, this doesn't exist in the real life, but it does exist in the imaginary world. It's 8i. The negative turns into I, and square root of 64 is 8. So that's why we always look at the denominator. Denominator tells us to find same number, how many times to multiply by. Okay? The numerator is just a display. Okay, just sitting there like a statue. We don't use it until the very end. The denominator is the key.
So root 3 and
1/3 power.
radical minus 64 is real, like applicable, or
Cube root of negative 64.
yes.
This is same as negative 64 whole thing to the 1/3 power.
Yeah, but can we put in the like square root, like minus number, because
So can you think of a number if you multiply 3 times, it turns into negative 64? Negative 4. So see, it does exist. It does exist because this is add. This is add. For odd number, it always exists, always. For even, it's hard because you have to make it even. You have to need a pair to make it even. For odd, it doesn't matter. It doesn't need a pair. It's just free. So it gives us something back always. Okay, now volunteers, who would like to try the next one, the first one? B1, 4 to the 3 half power. 4 to the 3 half power. Volunteer. Kathy, how about you? How would you like to rewrite the 4? Something with 2 power or something with 3 power? 2 power. So can you think of a number, if you multiply twice, it turns into 4? 2. So this 4, we rewrite 2 square. And then what happens? 2 cancel out. Excellent. So if you multiply 2 3 times, what do you get? 2 times 2 times 2. 2 times 2? 4 times 2? 8. So your answer is 8. Not bad. Okay, the next one. The negative, is it multiplying or it's in the base? If you don't have the parentheses, what does it mean? Is it multiplication or it's the base? The other way around. If you have a parentheses, then it's a base. If you don't have the parentheses, it's a multiplication. So negative times. What happens? Print mode? Why get into print mode? Why I hate that? It's even saving now. No, not PDF, not PDF. My bad. Okay, so we have negative extra. And then we rewrite. So how are you going to rewrite the 4? 2 square. And then what happens? The 2 and 2 cancel out. So what remains? First you have a negative, right? So you bring down negative 2 from here. And the 3 from the power. Be confident. Negative? Perfect. Negative is a multiplication and 2 cube is 8. So answer is negative 8. First one is positive 8, doesn't have a negative. Second one is negative because our negative is a multiplication. Now, who would like to try the next one? Negative 2 square. But what is negative 2 square? Negative 2 square becomes what? But what do you have on the base? -4. So, can you come up with an answer here? So what's the answer? Definitely this is wrong, right? So it doesn't exist because you cannot come up with an answer. If you rewrite this, since we have a denominator 2, let's rewrite this the square power, square root. So the square root -4 cube. And so denominator. It doesn't exist. That's what I said, the rule, the first one here. If your base is negative, you cannot have even denominator. So we have negative base with the even denominator. Automatically, it doesn't exist.
So let's say that was on the test, did you just explain that?
You just have to write even base, negative base, even denominator, and then doesn't exist. As long as you indicate these two, I'll understand. But if you do nothing and then suddenly I DNA, I will not give you points. Because how would I know whether you looked at your neighbor's paper, right? So show me something to tell me that you know what you're doing. Okay, so negative, positive, no more negative, positive. Now we're doing something only positive. It's a big number. 243 to the power 4/5. So let's keep our 4/5 and rewrite that big number. What are you looking for? One number to the what power? 4 power or 5 power?
5.
Good. Can you think of a number if you multiply 5 times? You get 243.
30.
So you may wonder, well, how would we know it's a big number and you're not able to use calculator? So you're going to use deduction. 243. Is it odd number or even number? Odd, because the last number is 3. So definitely the answer will not be even number, right? If you multiply even number odd times or even times, it doesn't matter how many times you multiply even number, the answer is always even. That means the result definitely cannot be any even number. The result has to be odd number. So you have to start with the smallest odd number. Besides 1, what's the smallest odd number? 3. So multiply 3 5 times and see what happens. If you don't get that, multiply 5 5 times, see what happens. If 5 also doesn't work, multiply 7 5 times. So in this class, all the number will be definitely lower than 10. Whatever number you have, the answer definitely will be lower than 10 with some power. Okay? So you can ignore all those even numbers because the base is not even. So start with odd numbers. And as he said, it's 3 to the 5. And then what happens? 5 cancel out. We had 3 on the base, 4 on the power. Let me do one. It means 3 times 3 times 3 times 3. So you're going to multiply 4 times, you get 81. And now from here, you have at least one question in the final exam. The next one, division. So previously the rule, if you have A over B to the power n, what was the rule? What was the rule we learned? A to the n over B to the n. We can do the same thing here. These 3, 4, we can put on the top and on the bottom. So we have 1 to the 3/4 over 256 to the 3/4. Now comes second exponent rules. What is 1 to the anything? Positive, negative, zero, decimal fraction, whatever. 1 to the anything is 1. So what do you want the numerator? Only 1. Because see, 1 to the 3/4, it doesn't matter, the answer is 1. But for the denominator, we have to rewrite. What you're looking for? One number to the which power? 3 power or 4 power? 4 power. So can you think of a number if you multiply 4 times? The answer is 256. 4. Perfect. So this is 4 to the 4. So in your exam, you actually have to multiply. What is 2 to the 4? What is 3 to the 4? What is 4 to the 4? And then figure out. So 4 power 4 denominator cancel out. We have 1 over 4 cube. 64. No. Yeah, 64. I was thinking about 16. Question? So how do you feel about this? Are these hard, complicated, confusing, easy, doable? What is your opinion?
This is simple, but like it's a lot of rules.
Exponent rules. That's why I told you memorize all those exponent rules. Once you know your exponent rules, you know what to do in any case. So for this, it's simple, rewrite the base, cancel, and then rewrite again. But when you have something like that, you have to use your exponent rules, and then you rewrite, cancel, rewrite. Okay. Now negative power. For negative power, it's exact same thing. There's only one difference, negative times diffraction. I suppose you have some rules here, but for some reason I don't. The rules we have is if you have x to the negative 1, anytime you have a negative power, it turns into a fraction. So this negative alone, let me change the color to red. This negative sign alone turns into 1 over. Whatever remains, you put down, which is simply 1 over x. So let me put the rules here. So x to the negative 1 means 1 over x. X to the negative 2 means 1 over x to the positive 2. Can you guess what is x to the negative 7? 1 over x to the positive 7. So that negative turns into a fraction, and then the power turns into positive. How about any number m? What would be the rule? One over x to the positive m. So the same thing, negative means the quantity is a fraction versus the fraction power. Fraction power means you have a radical, but negative power means the entire thing, the quantity becomes a fraction. For example, if you have 2, it's a whole number 2. But this whole number 2 will turn into 1/2 power if you have a negative 1 power. So see, without negative power, it's whole number. With the negative power, it's a fraction. Same thing, let's say we have 5. Without any power, it's a whole number 5. But if you have a negative power, it's 1 over 5, which is fraction 5. If you have, let's say, 6 squared, what is 6 squared? 36, right? Whole number 36. But if we have 6 to the negative 2 power, it becomes 1 over positive 6 square. So 1 over 36. So it's a fraction 1 over 36 versus positive whole number 36. So negative power turns everything, the whole quantity, into a fraction versus the radical. For radical, if you have x to the 1/2, it becomes square root of x. If we have x to the 1/3, it becomes cube root of x. So the base stays same, just the fraction turns into radical. But if you have a negative power, the entire thing changes. From whole number, it becomes a fraction instantly. Okay, now based on these rules, we have 64 to the negative 3/4. So 2 choices. First, turn this into negative fraction and then solve, or first solve and then turn into fraction. Either way. But the answer has to be a fraction because the answer is the power has a negative power. Okay? So I'll show you both. For the first one, let me keep the negative and simplify first. So if we simplify first, we need to keep our negative 3/4 power and rewrite the 16. How would you rewrite 16? One number to the which power? 4th power. So can you think of a number if you multiply 4 times, turns into 16? 2. So this 16 is 2 to the 4th. And then what happens? 4 cancel out. What remains? 2 to the negative 3. And now apply your negative power. How do you get rid of the negative power? Fraction 1 over 2 to the positive 3. And what is 2 to the 3? 8. You see, the answer is 8, but as a fraction, not as a whole number. And that's because we have a negative exponent. For negative exponent, the answer always has to be fraction if your base is a whole number. Now, the second method I was talking about was first turn this into a fraction. So if you turn this into a fraction, you get 1 over 16 to the 3/2 power. So you're going to rewrite 16 on the bottom. Now how are you going to rewrite 16? One number to the which power? 2 power, right? Because all this is 2. So what square will give you 16? 4. And then what happens? 2 to cancel out. So you have 1 over 4 cube. And what is 4 cube? 4 times 4 times 4? 64. We can do either way. First turn into fraction, then simplify, or first simplify and then turn into fraction. Either way will work. You will get the same result. Any question, comments? No? Okay, try this too. Actually, you have 4. Try this 4. And I didn't see that tendency yet, so let me check it now. Brandon is here. Liliana is here. Martin is here. Christopher is here. Axel here. Matthews went to the restaurant. Eliza here. Angel here. Handa here. Maria. Okay. Ashley here. Exona here. Jason here. Hattie here. Asim here. Kayla here. Krishel here. Calisius absent. Mariam here. Hey here. Chanel here. Jassim here. And John absent. 1, 2, 3. Oh man, 3 absent. Your exam will be for 1 hour 15 minutes. So until 2:15. Sorry, 3:15. Okay. Last time it was 3:30, but this time I have to give it 3:15 because I have my own final exam that day. So I have to go for early. So don't be late. Definitely don't be late on exam days. You can come around 1:30. I'll be here around 1:30. I'll try to be here around 1:30 and I'll give you the exam early, but you definitely have to leave by 3:15. We cannot delay, okay?
So 1:30.
You can start 1:30. but you have to finish by 3:15. Definitely by 3:15. I cannot give you any extra time. I cannot because I have to go Colombia. Okay? Let's do them together since we don't have much time. Who would like to do C? Volunteer for C. Martin.
Parentheses. Voice. Yeah.
This one, this one.
I have to do that. Like that.
It's okay, try this one together. So what do you think? If I keep negative 2/3, how you're going to rewrite 8?
One.
So you want to write 1/, no problem. So you're turning fraction, negative into fraction, 8 to the 2/3. And then you're rewriting 2/3. So what is 8? What number to the what power? This 8 is what number to the what power? What number to the 3rd power? Which number, if you multiply 3 times, turn into 8? 2. So this is 2 to the 3 power. And then what happens? Cancel out the 3. 1/2 square. And what is 2 square? 4. Perfect. That's it. Brenda, would you like to try the next one? -4 to the 3rd power. And we have -2/3. And then what happens? 3 cancel out. What remains? -4 to the -2 power. 1/4 to the +2 power. Great. If your denominator is odd number and your base is negative, still it happens. It's not doing For odd denominator, we always get an upward. For even denominator, we have a problem if the base is negative. Okay, who would like to try E? The next page, first one. Ashley, would you like to try it? 3 to the power of 5, and we keep our -4/5. 5 cancel out. 3 to the -4. And now we don't like the negative power. 3 to the +4, and that's how it becomes 1/81. You got it. Jason, would you like to try the next one?
Six.
1/256 to the 3/4 power.
4 power.
4 to the 4.
Cancels out the denominator. Multiply 4 to the power of 3 to get 1/64.
1/64. Great. He's correct, right? 4 to the 4 is 256. So that's all you have to do. Whether you have a negative power or not negative power, it doesn't matter. For negative power, it's become fraction. If you don't have a negative power, it becomes whole number. That's the difference. So Martin, none of them have answered DNA. Okay, now the last thing for the exam. Oh, probably you're not done with copying these, right? Does anybody need more time copying this? We are going to do the same thing, but with numerator and denominator. Okay, so let me skip these. And I'm talking about this. So directions is simplified. So it doesn't matter what we have. The thing is, we are going to apply the rules, exponent rules. We have more elements on the base and then one power. So step one, distribute the power. So we have 4 cube x to the negative 3 cube 6 to the negative 2 x to the 4 to the negative 2. Numerator has power 3, so we distributed 3. Denominator has power -2, so we distributed -2. So we apply the rule AB over C to the power n. Means A to the n, B to the n, over C to the n. So in this case, actually, we have different powers. But it doesn't matter, we apply the same thing. I shouldn't write C on the bottom. And now we apply more rules. 2 powers together. So second rule, A to the m whole thing to the power n. 2 powers together, what do? Multiply A to the m. So -3 and the power 3, what do you get? X to the -9. And the denominator, x to the 4 to the power -2. So what do you get? -8. Now, don't do anything until all the negative powers turn into positive. This 6 is the negative part, so don't touch that. Keep your 6 to the -2. But 4 cube is a positive number. So you can distribute that if you want. 4 times 4 times 4, what do you have? 64. So this is negative, don't do anything. This is negative, don't do anything. This is negative, don't do anything. Why? Because negative will mess you up. So always erase what you don't like. So our goal is to erase all these negative signs. Unfortunately, we cannot just erase them. We have to use the rule. How do you get rid of negative power? What do you do with them? Turn them into fraction. In other words, if you have a negative on the top, put it on the bottom, it will become a fraction. If you have a negative on the bottom, put it on the top, it is already in the fraction here, so it turns into a whole number. So all you have to do is all the negative things you see, get rid of them by changing or switching their position. The x to the -9 will turn into, come up on the denominator. X to the -8 will go on the numerator. Same thing this one. 6 to the -2 power, we'll put them on the numerator. So rearrange them before you go any further. So we have 64. It has no problem. It stays 64. X has a -9 power problem. Bring it to the bottom. 6 to the 9 goes on the denominator. Now from the denominator, 6 has a problem, -2. So put it on the numerator. 6 is a +2. Same thing, this one has a problem. Negative power. Move it up. So I don't have space, so let me put it 6 square and next to the positive 8. So see, three things. Numerator goes in the bottom, both denominators come up. And now everything is positive, everything has a positive power. So we are happy. We are going to use another rule. What do you do in division? How do you combine the powers? Subtract what from what? We subtract a smaller one from the bigger one. So which one is bigger, on the top or on the bottom? So we are going to keep our x to the 9, and we're going to subtract the 8 power from the top. Keep the bigger power on its position. Move the smaller one. Bigger one always has power. For example, big brother or big sister, they always have more power than you, right? If you're the younger one. So keep the bigger one, change the smaller one. Now on the top, we have 64. And what is 6 squared? 36. So now you have to multiply. 64 and 36. You have to multiply manually. 6 times 4, 24. So 4 goes on the bottom, 2 goes on the top as an addition. 6 times 6 is 36, plus 2 is 38. Then you leave one space blank, so you put 0, and then you multiply again. 3 times 4 is 12, so 2 goes on the bottom, 1 goes on the top as an addition. 3 times 6 is 18, plus that 1 gives you 19. And then you add the two things. 4 plus 0 is 4, 8 plus 0, 2 is 0, 10. So you put 1 on the top as an addition. 9 plus 1 is 10, plus 3 is 13. And then you put 1 as an addition. So you get 2304 over.
When you do the subtracting the x8 x9, you get rid of the top x, right?
Mhm.
I'm not gonna.
For example, x to the 8 over x to the 9. So 1, 2, 3, 4, 5, 6, 7, 8. 8 of them on the top. And you have 1, 2, 3, 4, 5, 6, 7, 8, 9 of them on the bottom. So all 8 cancel out all these 8. How many x is left? On the top or on the bottom? On the bottom. At the top we have 1, but instead of 1, we have this thing.
Yeah, that's what I thought. I don't know, my own investigation class, maybe I misheard, I thought that he told us to keep it. That's what kind of confused me. Okay.
When you combine the powers, the base is already gone. Okay, so try these two in your recitation Wednesday. And let me tell you what will be in the exam now before you read. Oh. So 4.5, one question. At least one. If I have a space, then I'll give you 2. But definitely 1. And I'll give you 1 from these 3. So all of these are combined, okay? From here, you get a lot. At least 7 to 10. Okay? Probably, I didn't make the exam yet. But definitely 1 full page of these exponents. Addition and subtraction, 1. From multiplication, 2 to 3. My plan is to give you one of these, and one of these, and one of these. So 3, this is my plan. And now 6 is gone, no more 6, no more 6, no more 6. However, all of these, I'm going to ask around 35 questions on the exponent rules. So one full page will be exponent rules. All of these rules. Not only rules, like for example, here you have A, M, and N, so they'll give you 2 to the 5 and 7. So you just have to multiply them and tell me 2 to the 35, okay? So using these rules, some examples. But at least one full page, around 30 to 35 questions. Chapter 6, completely ignored. 3 questions from multiplication, 1 question from addition.
And 35 questions from 5.1.
Not 35, 7 to 10. 7 to 10 questions.
Sure.
7 to 10 questions from here, 1 question from here.
What's
It will be
the-
only simple, huh?
What's the 35 questions? It's just
The rules.
Oh.
1 point each, 35 questions.
But there's only 20.
I'll give you more examples. For example, 1 to the any. This is 1 to the any. I'll give you 1 to the positive power, 1 to the negative power, 1 to the 0 power. See? So just remember your rules very well.
Yeah.
And remember, tomorrow no class, okay? Instead, whatever you have problem with, go over in your PLTL. And show them the thingy, the reading sheet. So goodbye, everyone. Good luck with the exam.